All right, so I'm going to start by adding a new class to our project. Let's call this string reverser. Now in this class, we're going to add one method that returns a string. We call it reverse. Here we need a string parameter. Let's call that input. Now the first thing we need to do is to create a stack to hold each character. So basically we're going to iterate over this string, get each character and store it in this stack. Then we're going to pop each character and these characters will come out in the reverse order. That's how we can solve this problem. So let's create a stack of characters and call it stack and initialize it like this. Now we need to iterate over this string and get each character at a time. There are basically two ways to do this. We can use a traditional for loop. So for int I equals 0, as long as I is less than input.length, we're going to increment I. In each iteration, we're going to call stack.push and get input.char at I. So we get the character at the given index and push it into this stack. That's one way. But there is a cleaner way to achieve the same thing. We can use a for each loop. So for each character in input, now here's the tricky part. In Java, we cannot use a for each loop on a string, but we can convert that string to a character array, and then we can easily do a for each loop on that array. So here we call toChar array. Now we have a character array, and we can use a for each loop to iterate over this array. Now in each iteration, we call stack.push and simply pass ch here. So unlike the previous solution, we don't have to work with an index and our loop is cleaner. Okay, so let's delete this. All right, so we pushed each character into our stack. Now we need to pop them one by one and add them to a string. Here's one way to do this. We declare a string, call it reversed, and set it to an empty string. Now, as long as the stack is not empty, we keep popping a character at a time. So we call stack.pop. This will return the character on the top. Now we get this and append it to our reversed string. So here's one way to do this. But the problem with this approach is that we have a lot of string concatenations. What if our input is 1,000,000 characters long? All these concatenations are going to be expensive because every time we run this statement, a new string object is created in memory because strings are immutable in Java. We cannot modify them. When you modify a string, a new memory is allocated and characters are copied into that new memory space. So what is a better way? We can use a string buffer. This class is used in situations where we have a lot of string manipulation operations. So let's initialize it like this, new string buffer. Now we call reversed.append stack.pop. This is way more efficient. Now finally, we need to convert this string buffer into a string and return it. So we type return reversed.toString. Now let's test this. So back to our main class, we create a string reverser. Then we call the reverse method, give it our string, and store the result over here. Finally, we print it on the console. There you go. So our algorithm is working properly. Now let's look at the edge cases. What if we pass an empty string here? Still good, no problem. What if we pass null? We get a null pointer exception. We got to fix this. So back to our reverse method. This happens when we convert this string into a character array. So to solve this problem, we need to have an if statement on the top. If input is null, we're going to throw an illegal argument exception. So if we call this method and give it null, this method should yell at us saying, hey, you gave me a bad argument. I cannot reverse this. So we're done with this exercise. We're going to look at another example of using stacks next.